Hey, what's going on everybody? My name is Caleb. In this video, we are going to explore the details of horizontal and vertical scaling. If you have no idea what that means, it's basically two approaches to bring an app from fewer users to many users. We did a video on how to scale an app to millions of users, and we talked about these concepts, but this video is going to go over them in much more detail and talk a little bit more about the theories behind you might choose one over the other. Doing this right can make your services perform better and save you money. So if that sounds cool, then this is the video for you. We're going to start by first sharing two resources, which I'll have links down below. The first is a backend engineering mind map, which will share a bunch of different technologies you should be at least familiar with if you want to be a backend engineer. This will be really handy as you continue to study system design and architecture, as this will give you a lot of the names for the actual services you can use in these different cloud providers. The second thing is a software engineering mentorship that I am running. This is a program where I help you learn the skills to be able to succeed at technical interviews and build your own applications so that you can be a competent six-figure software engineer. If this sounds interesting to you, which if you're watching this video, pretty good chance it does, then I'll have a link for that down below as well. In this program, you'll get experience working with high-level engineers, learn how to succeed at technical interviews, and get more experience building apps. So again, check that out. I'll have a link down below. And with that, we'll get started talking about scaling. Now, I want to prefix with one thing: in-house versus cloud. Your approach to scaling might be a bit different if you are running the physical servers versus in a cloud environment where it's much more virtualized. So most of my experience is in the cloud world, but most of these principles will apply the same for in-house. So if you are running the servers from your home or from a data center you can actually go to and see the computer, there's just a few things you need to be aware of. And if you're already running in the cloud, you can pretty much ignore this stuff, but it might be good to at least be aware of these if you ever are working in an on-prem environment. The biggest one is space and hardware limitations. So yeah, in a cloud environment, go ahead, set up 20 servers. You don't have to think about the space that those servers take up. With an in-house setup, you might not actually be able to add a bunch of servers just because they take up space. Additionally, if you have a server, it might make sense to replace a specific piece of hardware because you already have the server. In a cloud environment, everything's virtualized, so you can just switch to another server instance. No big deal, you don't have to worry about anything that goes on behind the scenes. And realistically, behind the scenes, they're probably not adding more RAM. They're just allocating more resources to your service. That's the idea of virtualization. You have your service here, and this runs on hardware, but these are not tightly coupled, and you don't have to worry about this layer at all. So that virtualization can change things a little bit, make it a little bit easier to try different variations of scaling. So keep that in mind as you go through this content. And if you're just getting into system design and you don't understand all of the details of this, that's totally fine. I'm just putting this at the beginning for those of you who are running things in-house, just to keep that in mind as I explain the different concepts in this video. I'm mostly going to be teaching from the perspective of a cloud environment. So you'll just need to keep these things in mind when you are talking about in-house or on-prem setups. So let's just do a quick definition so we're on the same page with what horizontal and vertical scaling is. Then we'll go into the details of the approach to choosing which one and the things you need to be aware of. So these are the two general types. So the definition for these: horizontal, you may also hear this as scaling out. And then for vertical, you may also hear this as scaling up. For horizontal, this is just adding more servers. So if you go from one puny, pathetic little server to instead having, for example, 5 puny, pathetic little servers, you horizontally scaled. Now, the key thing here is that you will need to make sure these all work together so it logically feels like one unit. So you can imagine this being an API. All 5 of these servers are working together to provide a single service. So the end user doesn't notice any difference. You basically will connect from a single front end to the API, and we're good to go. I just dropped my chalk. You see that? That was pretty cool, huh? All right, watch this. Oh, shoot. So we'll get into the details of that. For now, just know horizontal scaling is growing out, adding more servers. Vertical scaling would be going from a puny, pathetic server to a much more beefy, powerful server. So this might have 5 times the computing power, but it's still just a single server. So the idea of scaling up, you can imagine a skyscraper, building upwards, still one building, but it gets bigger and bigger and bigger. Versus scaling out would be building a city, adding more and more buildings. Now the question is, if you're given both of these options to scale an application to support more users, which do you choose? And the answer people will always give is it depends. So that's the end of the video. Thank you for watching. Nah, I'm playing, but I will give you some tips on choosing the right one, but it can vary a lot on the type of service. So what a lot of people don't realize is there's no perfect answer. If you're working with an API, that might be different than if you're working with a database or a front end or a cache or a queue. The type of service is going to change which one of these is ideal. And even within a particular type of service, so let's just take a look at databases real quick, the type of database you choose will determine which of these makes sense. So there's not an easy answer just to say, hey, always do horizontal scaling or always do vertical scaling. So we're going to instead look at some general rules which will help you decide in the majority of cases. To best understand this, I think it helps to start with one service type, understand the end-to-end for that, and then just think of how it differs for different service types. So the easiest one to learn this with is with a Backend API. Looking at the API is probably the easiest because first, it's stateless, so we don't have to worry about storing data like a database. And second, it's the most common service, so it's something the majority of you watching are probably already somewhat familiar with. Whereas if we get into database clustering, it gets complex very quickly, and it's something you're probably not working with every single day. Some of you perhaps, but the majority of what I would say backend engineers or full stack engineers, they're fairly comfortable with the API layer. So let's take a look at how we would scale this, and then we can talk about variations for other services like the front end or database layer. So let's draw a server. I'm gonna make it pretty big because I'm gonna write a bunch of stuff in here. And the main purpose of this server is to deliver the API. A few key things before we even talk about scaling. This needs to be stateless. Basically, you don't want to be storing any data about users or application-specific stuff on this server. So when you're running locally, if you imagine you're building software on your computer, you'll often have the API running and you'll have a database instance running on the same computer. It's definitely possible to run a database and the backend API from a single computer, but doing so in a production environment is probably a bad idea unless you're working with a very small service that you can just run from a single computer. As you want to scale, if you have the database inside of the server, and then you wanted to scale horizontally, so you have another server. Well, now, how's it going to work? Do you have 2 database instances? And then what if we write data to this database, but then the next time we connect, we try to read data from this database? So the idea of statelessness is we don't want to store any kind of app data in the server. So the fix for this is to have a separate database server, and then both of these will just connect to that individual database server. So now we have basically a shared location for all of the data storage. So that's the first thing you need to do when it comes to the API is get the database out of the server. You can have the database server separate, or you can have it running as a secondary service in the same server. For scalability, we want to get it outside. So let's first talk about vertical scaling, as it's probably going to be the first thing you do up until some point. And we're specifically going to look at what can you scale. So there are certain components to a computer. If you've worked with computer hardware, you're probably familiar with these. The big 4 that you need to concern yourself with are the CPU, the RAM, the disk, which will be storage, but it will also include whether it's solid state drives or hard drives. So not only the amount of storage, but the speed of the writes and reads. Fortunately, we don't have to worry about this a whole lot with APIs because it's stateless. We're not storing stuff to disk. And then the next one on here is network. We can look at each of these in a bit of detail, but at a high level, you basically will just look at the utilization of the server and try to get these fairly balanced. So let's consider a scenario where you have 90% CPU usage, 20% RAM, 20% disk, and 20% network. How would you vertically scale this? One immediate thought would be, oh, let's just double the server. But what is that going to do? That's going to now bring it down to 45% on the CPU and then 10% for everything else. So we're doubling all of these things that probably don't need doubled. So instead, we can just upgrade an individual component when we are vertically scaling. So this would be 2x for everything. And then let's go through a second example where we just 2x the CPU. Now, this might be obvious, but I'm just writing it out so we're all on the same page here. This is now going to be 45%, 20%, and 20% for the rest of everything else as well. Now, these are a lot closer. Another thing you should consider with all of this is the fluctuation in the processing. So for example, if we're generally at 45%, but that could go up to 60%. So let's just keep it simple and not worry too much about the consistent numbers and then peaks. Let's just assume these numbers are the highest amounts we would need at any point in time. So this would be like worst case scenario usage. So let's come up with a pretty good scenario of how we could set this up to not waste any of our money. We might try to get it to where we are using 75% of the available computing power, processing power at any peak time. Same thing with RAM, disk, and network. And this exact number, 75, you can adjust that. One thing to consider with this is those spikes in traffic. So if you push your processing to 90% at some points, that could be a concern. But if you're doing something like video encoding where it's constant 75%, maybe that's fine. You just don't want to set yourself up where you're pushing your boundaries and you're getting closer and closer to 100%. Then you get some spike and everything collapses. So what that perfect number is, the percentage of utilization, really depends on the service and how much variability there will be in that number. The less variability, the higher you can push that number because you're more confident you're not going to get spikes that push it up to 100. But in general, you want to keep a little bit of padding, so don't push these numbers too high, but you also don't want it to be at like 20% where you're wasting 80% of the computer. Now, logically, the reason for trying to get these fairly balanced is because if there's big differences in all of these numbers, there's a good chance you're overpaying for one of these or underpaying and not having enough of another. So by getting it pretty close to balanced, you're better utilizing the computer hardware. So now let's say the service starts to grow over time, you're getting more users, and as a result, these utilization numbers start to push closer to 100. Now you can vertically scale just by some factor. So for example, you could double the server, and that's going to cut all of these numbers in half. Now this is kind of like minor details here, but you might need to adjust as the server grows because the rate in which these demands grow might not be the same. So for example, you might double the server, but in that time of your application growing, the only thing that really changed was maybe these two. So you might not always need to double the server. You might just need to double individual components. But the ideal end goal is to try to get it to where you're not wasting a bunch of money on hardware that you don't need. So step one is to vertically scale, or you can really just think of this as adjusting the instance type to find that perfect instance which has the appropriate RAM, disk, network, and processor for the type of application you're running. If you're running locally, you'll need to figure out how to monitor all that. If you're running a cloud platform, they'll probably give you some dashboards and you can see if there are any bottlenecks. At this point though, you're probably not vertically scaling a substantial amount. You're not turning this into a supercomputer. This is really just to get things started, so that your hardware utilization is reasonable. Step 2 is to horizontally scale to at least 2 nodes. So we're going to talk about this and why this is important, but just to, give the full step-by-step here, you can then choose between vertical or horizontal. So once we get to step 3, we have a good setup, a good starting point, and then you can decide if you want to get better servers or expand to more servers. But you definitely want to do step 2 here, because if we horizontally scale to at least 2 nodes, then we have failover, higher availability. So let's go through both of these scenarios. So we'll do horizontal scaling here, where we add 2 servers, versus vertical scaling here, we just upgrade the server. This one is going to have higher availability because we don't have a single point of failure. Basically, these 2 nodes are going to work together in unison to provide the API layer. So if one of these goes down, we can direct all of the traffic to this one. Then whenever we can fix that server or replace it with a new one, and then redirect traffic back to it. So everything just works. The end user doesn't notice a disruption. Whereas in this scenario, if this server goes down, you're cooked. You have no fill-in server to take requests, so your service goes down. So that's step 2, go to horizontal scaling. This is going to introduce some complexities, specifically a load balancer, which is something that'll basically do that load distribution to the individual nodes. But this is usually fairly easy to set up in a cloud environment. And once you have that load balancer set up, you don't really have to do anything. It's going to do all of that magic for you. And it makes it very easy for you to then horizontally scale more, because you can just add more nodes to that collection there. Once you've set up the load balancer and you have at least 2 nodes, it's then up to you if you want to vertically scale or horizontally scale. I would say it probably makes sense in general to horizontally scale, but you probably don't want to be working with the crappiest instance types possible. So, maybe make them decent, so that way you don't have to have tons and tons of nodes for your service to effectively work. But fundamentally, there are a lot of benefits to horizontal scaling. This is specific for stateless APIs. Again, the approach might be different if you're working with databases, where having a bunch of nodes might be more complex. But there are database systems for that idea, so we'll get into that at some point. Let's focus still on the API layer, but just wanted to give that reminder. Let's talk about the idea of diminishing returns. You probably understand the idea of diminishing returns, but basically, as you invest more, you might not get the same output. You might get less output. Say, for example, you work out 5 times a week. That's pretty dang good. If you double that to 10 times per week, you might not be twice as fit. We can look at this from the perspective of computing power and money. So let me share a brief story. There was a girl that I went to college with who had a pretty expensive laptop. That's a laptop, not an L. It's like opened like this. And this was a nice laptop. Let's just say it was $800. But there was one problem with it. It only had 64 gigabytes of storage. And I'm in computer science, right? So everybody asks me to fix their computers. Why is this not working? Well, because you only have 64 gigabytes of storage, but you paid a ton of money. You paid a lot, but the computer's still effectively useless. So I just told her, hey, I'll take it off your hands. Don't worry about it. I'm just playing. But basically, there was an initial cost to the computer, regardless of what level of hardware was in the computer. There's a cost to manufacturing, shipping, all of that stuff. So even for a basically useless computer, it still costed $800. If instead she spent $1,000, she probably could have got a laptop that had, I don't know, if it was an Apple computer, probably 128 gigabytes, but let's just say 1 terabyte. And for such a small increase in money, we drastically increased the storage capacity. This is not an example of diminishing returns. The returns on this were extremely high. However, if we did this once more and we went from 1,000 to 1,200, she might have been able to get a laptop that had 2 terabytes. So here are our 3 scenarios. Let me just box them so we can see them nice and easy here. You can see in this scenario, we like 20x'd the storage for $200. But going from this scenario to this scenario, we only 2x'd the storage. And this is the idea of diminishing returns. There's just a cost to a laptop regardless of how good the hardware is. So in theory, there's like a perfect amount where you get the highest return per dollar invested. And I'm getting way off the rails here, but the idea of this is as you increase the money spent, you don't always get the same returns. So we started with a 20x almost increase and then went to a 2x increase, but the amount of money increased was the same. And I bet if you doubled the money, so a $2,400 laptop, you're probably not going to get a laptop that's exactly 2 times as good. It might be 1.5 times as good. So how does that story have anything to do with what we're talking about? I have no idea. I just thought it was funny because her parents bought it for her thinking it was like this really amazing laptop, but it was pretty much useless. But anyways, you can basically assume that the cost of computing hardware is exponential. There's some point in this chart where it makes sense in terms of best ROI, where it hasn't gone, crazy yet, but we're not down here where we get zero performance either. So maybe it's right here. I can't say exactly for sure on this beautiful diagram, but somewhere in this line, there's a spot that makes pretty good sense. So she bought, maybe right here. That's where that laptop was. And for just a little bit of extra money, she could have got a massive improvement in performance. From this to like this, so like 3 times on this little chart. But then to do that again and increase the performance by the same amount, it would cost drastically more. So we might be getting the same boost in performance, but the cost has gone from here all the way up to here. Hopefully that idea makes sense. The general idea is as you go higher and higher in computer hardware performance, the cost is exponentially more. Doubling the hardware doesn't really translate to a 2x cost. So what's the solution for this? Well, with a laptop, it doesn't really make a lot of sense to split it across 2 laptops. Now you have to carry around 2 laptops everywhere. But when we're talking about deploying applications, you definitely can horizontally scale. The thing to keep in mind with horizontal scaling, especially if you're using this idea as the framework to think about this, there is a cost to adding another computer regardless of how good that computer is. So for horizontal scaling, we have a pretty steep cost up front. And I'm gonna erase these markers here because it's not all gonna line up perfectly here. But once you pass that initial cost of getting the actual computer, it then makes a lot more sense. Like if you needed to store 200 terabytes of information, it would probably be a lot cheaper to do 20 terabyte drives, 10 of them, versus finding a 200 terabyte drive, which I don't even know if that's a thing, but you get the idea. Horizontally scaling makes sense at some point. Once you get past this initial cost, it's going to be a lot cheaper to horizontally scale. So the point at which you switch from vertical scaling to horizontal scaling would be when horizontally scaling is cheaper to increase the performance, which is going to be about right here where they cross. So horizontal becomes cheaper than vertical scaling. So what that means is if in whatever scenario you're in, you're on this side of this imaginary line, and you need to start growing, which one is going to be more cost effective? It's going to be vertical scaling. But then at some point, the cost is going to get extremely expensive. So at that point, it makes more sense to split it out into multiple servers for horizontal scaling. So this is basically like the theory behind everything. You don't necessarily need to understand all the details of this chart, but the idea is that at some point, horizontal scaling makes more sense because the cost to increase the hardware vertically is more than the cost of adding another computer. So hopefully that chart helps you understand fundamentally the difference in cost for horizontal versus vertical scaling. Within a virtualized environment, if you're working in the cloud, there may not be a more than 2x increase in cost for doubling an instance size. And that's probably due to that virtualization. It doesn't actually mean they are replacing your hardware with new hardware. So practically those theories might not apply in your cloud environment, but just something to be aware of. If you're on an on-prem environment, then it's definitely going to make sense. As you double the hardware, the cost is going to be more than 2x the cost most of the time. So for example, if you go from a 16-core CPU to a 32-core CPU, you're getting roughly 2x the performance from this move, but this 32-core processor is probably going to be more than double the cost of the 16-core processor. So for example, it might be 2.5 times the cost. Cool, so we talked about scaling with a stateless system. This is fairly simple. You can just horizontally scale because there's no data being stored. It doesn't matter which server you connect to generally. So that's fairly straightforward. Just vertically scale to the point where you have, a system that works and you're not paying for resources you're not utilizing. Then horizontally scale to at least 2 units for the failover benefit for high availability. And then it's up to you to choose between horizontal and vertical scaling. Generally, a system like that will scale horizontally quite nice. Now let's talk about some systems that might be a little bit different. So we'll specifically look at the database, but I want to get into the front end real quick. Most likely this is not a huge concern because it's usually really easy for the front end. So specifically, you can use serverless hosting such as S3. That would be the AWS option. And this will allow you to host the front end, and the cloud provider takes care of all of the server stuff behind the scenes. You just pay for usage. And because the front end typically is not very complex, HTML, CSS, JavaScript, this works very well, and you don't have to worry about vertical or horizontal scaling or anything. So front end's kind of taken care of for us. Now let's take a look at the database layer, which, by the way, there are serverless options for these other tiers, so the Backend API and the database layer. So that's something you can look into as well. So for example, AWS Fargate or AWS Lambda, you can look into those for backend services. And then there's AWS DynamoDB, which is a serverless database. We've talked about the idea of serverless in previous videos, so we're not going to get into the details of that here. Basically now I want to talk about what it looks like to scale a database if you're not in a serverless environment. So this first approach is going to be more common for relational databases. So if you're doing something like Postgres, and that is to prioritize vertical scaling. And by prioritizing first vertical scaling, you remove the complexities of horizontal scaling when you're working with a stateful service. A database has to store data. If you have multiple servers, now you have to think about how do we get the data across these multiple servers, or if the data is split across the servers, how we know which server to access to get the right data. There's a lot of complexity introduced when you horizontally scale a database. So the first scenario would be to just focus on vertical scaling, creating a bigger database server, and you'd be surprised some of the instances that are available for this kind of thing, where you can have basically a supercomputer running your database and you don't have to horizontally scale. So you could just have one database instance, boom, you're good to go. Now, there are some downsides to this. As with everything, there are trade-offs you need to evaluate. So one of the big things is a single point of failure. So there's an easy solution to this, and that is to have a stand-in database. And this would be a database that's synchronized with this database, but is not actively used for reading or writing. It's kind of just there in case something goes wrong with the main database. So I'll just kind of draw that in the background here. So that's the first thing you can do. That will help with high availability, because if the main database explodes, you have another database server ready to go. The next thing you can do, which can help and still avoid a substantial number of the complexities of distributed databases, is to have read nodes that are only used for reading. So we could copy the data from this database over into some other nodes, and we could also distribute these across different regions, so the data could be closer to the APIs accessing them, for example. So these would be used for reading, and then this main one would be used for writing. I think we talked about this some in the scalability video, but just for comprehensive sake, we'll go over here again. In this scenario, we can now scale the write node independent from the read nodes, so you can adjust based on the application and what needs it has. So if you're doing a social media network, the feed is a lot of reading, but you write only every now and again. You might make a post once a day, for example. So you could have more reading compute power and less writing compute power. But if you're in a scenario where it's instant messaging, for example, well, that's very write heavy and read heavy, so you might need to have these more balanced. But you can adjust them independently to meet the needs of the application. The only downside to this is you still only have one write location. So say you're connecting from one continent and the database is in a different continent. Well, there is a substantial distance between these two, and that adds latency to any requests. Whereas reading the data could be pretty quick. So if either the latency is a concern, or if you just want to be able to scale the writing beyond just a single node, which, reminder, this node can get pretty overpowered. So you might not even need to do that. You can probably run the majority of applications from a single instance. But if you're building, the world's biggest social media network, this may not be adequate. And in that scenario, you might need to look into multi-master clustering. So when we say multi-master, the term master typically just refers to the write node. So you might hear it as master, and then you might hear of these ones as slave nodes. But in a scenario where you have multiple write nodes, you then have to worry about the complexities of clustering. But it's not impossible. It's not like nobody's done it before. So I'm kind of saying it's complex and I would avoid it if possible. But if you need it for something, then yeah, it obviously makes sense to do it. It's just don't do it if you don't need it. That's one of the problems people often do, is they over-engineer everything and optimize prematurely. If you're to the point where you need multiple write nodes, then for sure, go for it. I'm not telling you not to. Just don't do it if you don't need it. So we're not going to get into this in detail in this video because we're going to do dedicated videos on database clustering in this series so we can get into all of the good stuff. So this is horizontal scaling in the database world. In the previous demonstration, we horizontally scaled just the read nodes, basically copying the data over to these read nodes. That works just fine. When it comes to writing, it gets a little bit more complicated. And this is basically what you would want to research if you needed to horizontally scale the write nodes. The database of choice is going to impact how this works. So I can't give you like, hey, here is exactly how it works. Every database has its own approach, and there are different ways to make this work. So that's why I just want to do a dedicated video for it. Now, if you're working with a NoSQL database, these are usually more commonly used for multi-write systems. So if you were to build like a messenger app that's pretty heavy on the writes and the reads, pretty common for something like that to use a NoSQL database for these reasons. They are by default built for this purpose, so you immediately get some of those benefits. So again, I look forward to talking about that in more detail in the upcoming videos. So that's the overview of vertical horizontal scaling. That's all we're going to get to in this video. But again, we'll have more videos coming up that go into the specifics for different systems. So definitely check those out. I did want to remind you of the links down below. We have that mind map for backend engineering, which will give you an overview of the different technologies you should be familiar with. And we have the mentorship program. So if you want to get connected with high-level engineers, learn how to become a high-level engineer, definitely check out that link down below. So if you're looking for the exact answer of what to do in terms of vertical versus horizontal, this video is pretty much just a long-winded way of me saying it depends, and do the research you need for your specific application and experiment. It could be for your particular application, it works best on a particular node size, and that might help decide at what point you should switch to horizontal scaling. There are so many inputs that affect this. The main thing you need to understand is that the idea is that we need to cover more users. There's multiple ways of doing that. Experiment with what works best and just make sure the service is good. So I know that's kind of like ignoring the obvious question, but that will give you a good framework to think about this and make good decisions on which way to go. Thanks for watching. Peace out.